Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to be taking a look at properties of logarithms and properties of logarithms and also the quotient property and the power rule property. So let's go ahead and get started. Now, we're going to start with the quotient property, and to really understand how this works is you need to remember the product rule or the product property or whatever you want to call it. So with the product property, you have the following. You have log b times the quantity of m times n is the same as, or is also log base b times the quantity of m here plus log base b times the quantity of n. So when we're dealing with quotient is about dividing. In other words, a fraction or dividing, divisor, whatever you want to call it. So since this is adding together, well, the opposite of multiplication is division, or the inverse or the opposite of addition is subtraction. So we just go with the thought here, and you can just tell already that if we have the following log base b times the quantity of m over n, well, it's just going to equal the following. It's going to be log base b m minus, let me make that a little bit clearer, minus log base b times the quantity of n. So you can see that. And just to make sure that this is clear, why don't we go ahead and do an example here on the next screen here. Alright, so here's what we have. Let's just say that we have the following. Log base 3, our favorite base, times the quantity of 27 over 9. Just work with the argument, just work with what I'm doing here. So the first thing we have to do is that we have to put our 27 and our 9 so that it has the same base as our log right now. And so to do that, it'll be equal the same as the following. It'll be log base 3 again. And then inside the parentheses we'll have 3 to the third power over 3 squared. That's what we would have. Now, since these have the same base here, this 3 to the third, let me give you a different color. Since these have the same base, we know we're familiar with our exponent properties. It basically can equal the following. So we have log base 3 still, but now to simplify things, we have 3 to the third power minus the second power, like that. That's essentially what we're going to have. And so now, because we're familiar with our logarithmic properties, because they have the same base here and here, we can simplify this even more. And so we end up with 3 minus 2 because these eat each other basically. We talked about this in a prior video. It's called the inverse property, one of the first ones we talked about. So we end up with 3 minus 2, which equals 1. Again, that's the answer essentially. So in other words, when you have logarithm of base 3 times the quantity of, or with the argument of 27 over 9, excuse me, it's the same thing as the following. If I wanted to write this out as formally as possible. So you would say log base 3, 27 minus log base 3 times the quantity of 9 equals 1. And that's the same thing as what we have up here. Because log base 3 times the argument or the quantity of 27 is going to give us our answer of 3. And then log base 3 of 9 is going to give us our answer of 1 right here. And 2. I'm sorry. 3 minus 2 is 1. So that's what's happening in this example. You can see that it works out clearly. Let's go ahead and do the next one. So the last one we're going to do is the power rule. The power rule is as follows. And this one's a little bit harder to explain with an actual example. So we're going to use a kind of a general example. Log base b times the argument or the quantity of m to the p power equals the same thing as p times log base b times m. That's what's happening here. So to do this one, it's a little bit trickier. So the first thing we want to do is we want to take a look at how can we make this a little bit clearer. So this is what we do. Again, it's hard to do this one with numbers. So log base b times m to the p power is going to be the same as log base b times b to the x, I believe. Yeah, x raised to the p, like so. And what we're doing here is substitution basically. And so because these have the same base, you can see that they essentially eat each other, and we're left with x. Okay, wait, hold on. So what happens here is as follows. First, we combine these two right here. Let me explain that and slow down. And so what happens is that we have log base b raised to the b times xp. Again, this is, you have to be familiar with our exponent properties here. And so again, being familiar with the inverse property, we know that these basically eat each other, and you're essentially left with xp like so. All right, and that's what happens here. And so now we do more substitution, and we end up with the following: log base b m dot p like so. We got m times p here, and then what happens is that when you complete the substitution, because we have to do something with the x, we end up with the following. We end up with the quantity of p times log base b m. That's what's happening here. So you can see that this is a little bit trickier. So what happened was that we put the x in there temporarily, and then we substituted the m for the x. And so what happened was that this is the same thing. These are the same. This and this guy down here are the same. All we did was we just put the p in front of the log. That's it. And that's kind of how it works out. Again, the power rule is a little bit harder to explain in terms of, you know, how it works out. But you can see that by rearranging things, that it works according to following the principles of how you can deal with logarithms. So let me go back and explain what we talked about, and then we'll conclude this video. So in this video, we talked about the quotient property and the power rule when dealing with logarithms. And so when we talked about the quotient property, I first talked about the product property, if you will, of logarithms. Basically, when you have a logarithm with whatever base times the quantity is the same thing as log base b times that quantity plus the other quantity. And so since the opposite of multiplication is division and the opposite of addition is subtraction, the same idea holds when you're dealing with the quotient property. So now you have the minus sign in here. That's the main thing that's different. And so then we went through an example of this where we had log base 3 over 27 over 9. First, we had to make sure everything had the same base. We used our knowledge of exponent properties to deal with this. We used our knowledge of the inverse property for logarithms to deal with the bases here. And then we end up with our answer as shown below. And that's kind of how it works. Now with the power rule, it's a little bit harder to try to explain. But what we did here is that what happens here is that when you have a raised to an exponent, the simplest way to understand that is that you take the exponent right here and you dump it in front. That's the easiest way to really think about it. The proof is harder to understand and explain at this point, but it kind of remains the same. So what we did here is that we substituted x for m, and we kind of went through the process here. And then when we were done doing that, we put the m back in for x. And then all we simply did here was that we moved the p in the front. That's all that happened there. And so this is kind of how it works out if you want to try to give a proof of the power rule. And so, having said that, I hope this video made sense and it was clear and you were able to understand what was going on. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.